20 years ago, one message was sent to the Ruby dev mailing list. Ruby dev mailing list is a Ruby community, Ruby interpreter developer community in Japanese language. The message proposed one virtual machine written by him. So he has a time because that was New Year's holidays. So in Japan, there is no Christmas holidays, but there are some New Year's holidays, and he has a time. He was a PhD student, and he has experience to implement the Java virtual machine written in C++ and in Ruby. So the Ruby Java virtual machine in Ruby was his first Ruby application. So he studied C Ruby internals, and so reading the book, and he thought so he can make better Ruby interpreter by using the virtual machine techniques. So after that, the Ruby 190 was released after the development of the very first version of Ruby YARV at 2007, and Ruby 191 was released as in 2008 as a production release, quality release. After that, maybe on your laptop, when you run the Ruby command, then the YARV will be run. So it means that his software runs on your computer. So his name is, of course you know, so Koichi Sasada, me. So I'm a Ruby interpreter developer employed by Stores Inc., so Japan domestic company. So the Stores Inc. Allow me to work to make a Ruby interpreter to improve the performance, improve the quality, and so on. So I never work on the Stores production, but I joined. So Stores support me to make Ruby interpreter. So after YARV developed, so I created some other low-layer softwares like a garbage collector, so threading system, debuggers, and so on. And I believe that I'm a shortest description for this this site. So anyway, so this is not related, but so yesterday, so we discussed about the sustainable open source software development. So fortunately, Stores, so my company supports me enough, so I don't need to this kind of sponsorship. But this sponsorship will become my cup of coffee. Anyway, so after the very first version of the very first version of the YARV, then I changed my job here. So the Stores was the fourth company, fourth position, but my development career only on the Ruby virtual machine, developing the Ruby interpreter. And also, I went to several Euruko conference here, and here. This is the fourth Euruko. So I'm very happy to have such a many opportunity to show the presentation on the European Ruby conference. And I'm very happy to visit very wonderful places like Sarajevo. So today, I want to introduce the 20 years of the YARV development. So I spent 20 years to make a YARV virtual machine, and so I have good achievements, and also I have some regrets. So this presentation, I want to share the idea about that. So first of all, so maybe most of people in this hall making a Ruby on Rails application. So maybe make a Ruby on Rails application on many huge number of libraries like that. And the Ruby interpreter is here. So Ruby interpreter is lower layer of your application stack. So this is maybe ordinal view from the Ruby programmers. From MRI, CRuby developer, so we see that all of Ruby script is same. So Ruby script will be interpret as a Ruby program and run it. So Ruby interpreter pass the Ruby script to the abstract syntax tree here and translate to the Ruby's bytecode here and evaluate by the evaluator here. So this is a very simple diagram of the Ruby's execution. So the Ruby interpreter is separated to the two parts. So reading parts and the evaluation parts. So in this case, so we can say that the Ruby interpreter do only two things: reading and evaluate, run it. So you understand most of things of Ruby implementation just now. Anyway, so YARV is here, so making the bytecode and evaluates this bytecode. Of course, without any other systems like the garbage collector or threading system or embedding classes or methods like string or array. But so we say YARV, then this part and this part is YARV. So today I want to show something about this area, this part. Before the detail of the technology talk, I want to show some topics. So why there yet another Ruby virtual machine? So the answer is that there were several Ruby's virtual machines in 2004, 20 years ago, and only YARV completes the implementation to run the all of Ruby program. So all of Ruby program means that there is no exception. No, so YARV do the exception handling. So it means that So all of the specification will be covered by the YARV. And also, computer science people like the yet another terminology like YAC system. Okay, so the introducing the basic ideas about the YARV. So this is a very beginner for the how to make an interpreter. So we introduced the stack machine model. So all operations using a stack. So for example, all of the calculated result to push to the stack, and the all needed parameter will be popped from the stacks. So actual computer, so CPU using the register machine. So because it is faster on the physical model, but on the software virtual machine, so the stack machine is used. There are many advantages and disadvantages, but so mainly the stack machine is easy to implement. Java virtual machine, .NET virtual machine, Smalltalk virtual machine, and the Pascal virtual machine, and many other language interpreter uses the stack machine model. So before Ruby 1.8, we evaluate the AST abstract syntax tree directly like that. So the Ruby program A equal B plus C, so very simple Ruby program will be passed as with this AST, and evaluates the node and evaluates the next node recursively like that. And the method, the result will be assigned to the local variable A. And after YARV, we translate, we compile this AST to the stack machine, like that. So running this one and using the stack, the calculation will be proceeded like that. We can see the actual assembler code with disassembly feature, and this website is shows the Ruby code to the disassembly code. So actual compiled code is this one. Better. So the compiled code we can evaluate on the virtual machine. Anyway, so another basic idea of YARV is automatic generations. So we define each virtual machine instruction in one file, and this file generates all of the virtual machine system, like the execution code and the virtual machine metadata, like how many instructions are there or something like that, and also the disassembler or the serializer, and also documents. So we don't need to make we don't need to write boring code like getting the value from the stack and so on. And also, this abstraction helps us to optimize more and more. So this is an example of how to write the instruction. In this case, so this text defines the get local instruction And there are other three metadata. So one thing is operand, instruction operand, and how many values should be popped from the stack here, and which value should be pushed to the stack after this instruction here. And with this information, the instruction body is written in C code like that. And this instruction definition translated to the actual execution code for the virtual machine. So this part is fetching the values from the instructions and stack. And this is a copy of the instruction body. And after that, we need to push the value to the stack. So this kind of code we need to maintain, but we can this kind of code will be automatically generated. So we need to we don't need to do anything about that. So this is repeating the message about the automatic generations. So easy to modify and introduce the instruction. So we don't need to anymore. We only need to write a method instruction definition, and we don't need to do write anymore. For example, for the disassembly or something like that. And also, it will it makes more optimizations. For example, if we find that this instruction with this operand, then we can make a special instruction, this one. So this kind of specialization improves the performance, and this so without the automatic generation, we need to write each instructions by hand, but we can ask the system to combine this kind of instruction and operand. Then we can make one instruction, another instruction easily. And also, we can unify the two instructions to the one instruction by automatic system. And also, we can use another techniques like the stack caching, and we can employ another dispatch method, instruction dispatch method. I don't show detail about the techniques, but we can choose. So the important thing is we can choose easily for such a which technique we should use on this platform. Another idea is optimizations. So the motivation of the virtual machine is to improve the performance of Ruby execution. So we can employ many known techniques for the virtual machine to the Ruby. So we need to know what is a Ruby is. So Ruby has many features and so characteristics. So we need to know the characteristic and choose which optimization is effective or acceptable, or so we can make it or not. So the first one is the nature of dynamic. So Ruby is very dynamic language. So it will be a limitation for the interpreter optimizations. So, for example, when you write a class syntax, method definition syntax with def, all of the execute so definition will be done in dynamic. So it means that you can, so usually we use if syntax, condition syntax, so which method definition should be applied on this code. So it means that the method definition is very dynamic feature. So, and also we have eval or some other metaprogram features like class.new or something like that. And we can also load any Ruby code with require, outload, or something like that. So we cannot know which code will be run before running. So it is very dynamic aspect of Ruby. So for example, so please see the 1+2. So very simple Ruby code. So other other language like C, so this 1+2 code will be converted to the 3 before running the program. So it is very easy to know. So 1+2 it should be 3. But on Ruby, it is not true. So we can redefine integer plus with your code. So we can't expect this is 3. So Ruby has this kind of limitation for optimization. Another aspect of Ruby is there are many method definitions. Method invocations. So most of operations, such as array, accessing to the array like that, or accessing to the instance variable like that, they are all method invocation. So Ruby program makes many method invocations. So we need to optimize this kind of method dispatch. To overcome this this situation, we introduce some technique like method caching or specialized instruction. So with such a non optimization, we can improve the performance of Ruby interpreter at Ruby 1.9. And the other optimization is method invocation with a block. So, for example, this is complicated program. Make a proc, and the local variable I should be has a lifetime longer than the method definition method call of this call G. So it means that we need to store the local variable I for this block. So it means that the block calling the block means we need to make a closure. So encapsulate the local variable for the block and use it for the calling the block. However, the making the closure, so encapsulate the local variables take a time. So this is what the Ruby 1.8, the reason why the Ruby 1.8 was slow. And so YARV delayed that this escaping, this encapsulate on the making the closure if it is needed. So remain the all of local variable when it is not needed. So this technique improves the Ruby execution very faster. But this technique introduces a huge complexity. So to implement this feature, I rewrite many times in virtual machine code, and I need 1 month, 2 months, 3 months to debug this feature. So it was a very difficult feature for me. We introduce other optimization like that. I don't explain everything, but maybe many optimization will be was applied because we can make a virtual machine. So this that was overview of what is a YARV and what the YARV did. So next, I want to show the goodies and bad points for the YARV. So maybe the most valuable achievement is definition of the Ruby virtual machine itself. So defining Ruby with stack machine instruction is not trivial things. So because Ruby has many specifications, such as complex method parameters and block parameters and complex control flow like exception handling or the break, next, redo, anything about the control the block operation, and also the special cases for ease of use. So I mean that we say Ruby is a programmer's best friend. So because Ruby supports many syntax, many specifications to use easily by the Ruby programmer, but Ruby is not best friend for the interpreter developers.
Thanks for doing the job anyway.
So YARV splits all of the specification and re-implements them. And then we can apply the many optimization with the virtual machine instructions. And also some tools like JIT compiler or type analyze system or the debugger rely on these instructions. So anyway, I say that the method definition is complex. Method parameter is complex. So I show some example why Ruby the method parameter is complex. Can you explain everything about that? Ruby has many type of the method parameters and many other exceptional cases. And also, block parameter has more and more meaning. So for example, this code and this code has different meaning. So we need to understand what's the specification and how to implement them. So this is another topic of the YARV. So when we define the instructions, so I choose the human readable instruction like that. So for example, the CPU instructions like the very small name like the two letters like that. But I frustrated to read the magical assembly code, so I choose human readable code. Anyway, so after that we define the virtual machine instructions for YARV, and the bad point is not well-defined instructions. It means that so there is a concrete specification for JVM and as .NET virtual machine or other virtual machines, and it is compatible, so they can rely on the specification of the virtual machine instructions. However, as I said, that YARV is designed too easy to change. So it conflicts the ideas. So I think that if we have any problem, we can change the instructions. We can introduce new instructions. However, the tool author, from the tool authors, the specification of instruction should be concrete. So it should be compatible with the any versions. So this is a conflict of the idea. So from Ruby 3.1, so YJIT was introduced, and YJIT rely on the current instruction set. So nowadays it is hard to change the instructions. So it is easy to introduce the new instruction, but it is difficult to change the current instructions. So this is another topic about the YARV. So JIT compiler is well-known technique to improve the performance, and I didn't release any just-in-time compiler. So this is the one reason is I don't like writing the assembler code for directly for each CPU architecture like ARM, Intel CPU, and so on. And also, I had thought that the just-in-time compiler was not viable to pay effort more because so it takes so there are some reasons. For example, the garbage collector before the generation of garbage collector, the overhead of garbage collector occupies the execution cost. So if we introduce the just-in-time compiler, but the GC is too slow, so the performance gain is not enough. And also, so we need to pay many effort to maintain the just-in-time compiler to support multiple CPU architectures, continuous maintenance, and catch up the recent Ruby's syntax changes and so on. So because we have limited developer resources, so I think it is hard. I thought, but the Shopify people organize a team and pay much effort, and they realize the YJIT. So I respect the achievement of the YJIT. And also, when we introduce the just-in-time compiler, why virtual machine is needed more? So this page is quoted from this another presentation, and this so that presentation shows that there are many releases in a day. So maybe 1 hour or half hour, they release a new version, and they need to reload the application. As you know, the just-in-time compiler, we need to take some warm-up time, like that. So after the minutes, so the performance is better, but without the warm-up time, the performance is not better here. So if we improve the performance of the virtual machine without the just-in-time compiler, then the performance of application become better and better, like here. So, so I think that improve the virtual machine performance is important nowadays too. Anyway, another good achievement is optimization for method dispatch. So I introduced the method call. Optimizing the method call is important for the virtual machine or for Ruby, and we pay huge effort to optimize the method definition. So at Euruko 2015, I introduced some techniques to improve the performance of method definition, and also this part of the implementation was rewritten many times. But there is no inlining, method inlining technique. So to eliminate the method dispatch overhead, so eliminates all of the method dispatch, but embedding the cold code to the Cora code. So it is known as the inlining technique. But the inlining technique is not employed by the virtual machine. I heard that YG team does some case of Ruby code. So in future, I think that it is valuable to support the method inlining on the virtual machine layer too. Another optimization technique is specialized instructions. So introduce a specialist instruction for some method. So lightweight and frequent built-in method like the integer plus, so string empty question, string size methods. So they are frequently used, and it is enough small methods. So the overhead of method dispatch is method dispatch consumes the time for these methods. So this technique, so introduce an instruction for each method, is easy to implement and easy to improve the performance. For example, so the 2004, so 5 days later, after the first report of the YARV, so I can report the 3 times faster on the Fibonacci example with this technique. So this technique like that, so checking the receiver and the parameter, and the both, we check the both is fixed num, and the integer plus is not redefining, then we can use the special additional function for the fixed num. And also, so we check, after that, we check if it is not a fixed num, then we check the floating, this is floating number or not. And if it is their floating number, then also we can use the special code like that. And this technique is for all of the plus method invocation. Then, so if the object is not a string, floating, integer, or some specialized one, then call the normal method dispatch. So this is an overview of the example of how specialized instruction does. But the regret of this technique is it has poor extensibility. It means that so this technique is for the lightweight and frequently built-in methods. So, but it is difficult to determine which is the lightweight and which is frequent. So, of course, it depends on the application. So some application calls the string size, but some application doesn't. So it is difficult to determine how. And so for Rails user, so there are some method which is called frequently, and other sides, the other application, it doesn't call. So it is difficult to determine. And also, it slows down the user definition code. For example, user-defined class, the plus method. So we need to check all of the specialized codes. So for example, checking the integer, checking the floating, and then the calling the actual method. So it has some overhead for that. So it means that there is no extensibility. So it means that we need to register this kind of specialized instruction by application, I think. So there is a room to improve the performance with this technique. Another topic, so block management. So as I said, it's optimizing the method with a block. We introduce a lazy block creation technique. So it was very nice achievement, I think. But it is not there is not enough optimization for block dispatch. So as I said, that method dispatch, I make many effort. I make many optimization, and it was very fast, faster than all the Rubies. However, the calling the block is not optimized because the specification of block parameter is very, very complicated, and I think it seems very difficult. So I didn't touch this optimization. So maybe it is a good room to optimize more and more for Ruby implementation, Ruby program with virtual machine layer. Another good achievement is I introduced some way to access to the instructions. For example, so as I show the human readable disassemble code, I introduced one method, and we can translate to the instruction sequence to the array, and the Ruby program can use them. And also, I introduced two binary methods to represent the packed binary representation, and this method is used by the boot snap. Maybe you are using on your application. And also, I support the prelude.rb. Maybe normal Ruby programmer don't know about that, but before prelude.rb, we need to write all of Ruby method in C code for the built-in method. However, so after that, after we introduce the prelude.rb, we can write any Ruby code to this file, and the Ruby interpreter reads this code before running your application. So it makes more readable and easy to implement more and more methods for the built-in classes. This presentation is quoted from my 2008 talk at Ruby conference. So it means that C Ruby is implemented and has a good performance. However, Rubinius was written in Ruby. So Rubinius will overcome the C Ruby because most of the code written in Ruby, and it is easy to optimize more and more with compare with the C implementation. So I think this prospect is correct, I think. So now some code is implemented in Ruby, and it is faster than Ruby, faster than the implementation by C. So I achieved some good things, but so there are some rooms to improve more. So we need to load at boot time. So if we increase the increase the implementation in Ruby, so it takes the time to load. So it is a problem. So we need to eliminate this loading time more and more. So we have some optimization technique like lazy loading. So for example, if we require a file, for example, file utils is a very common library, and maybe only one or two methods are used on your application because so file utils has thousands of lines, but only few lines are needed for your application. Then so we only need to load these few lines, only few lines for the application. It should be enough. So this kind of lazy loading technique is implemented but not activated now. So I want to activate it, enable it for more loading time performance. So I introduced some achievements and my regrets for the YARV development in 20 years. And I want to have, I have some future works. I want to do some more and more tasks. For example, more optimization for the method inlining, optimizing the yield, and the lazy loading for the faster bootstrap. For example, for your Rails applications. And also, I want to do some more research projects, like a flexible JIT compiler. So I talked about that YARV is designed for easy to modification. So I want to inherit this idea for the JIT compiler. So this is only a research project, and I don't think it is. It can be practical more for the compare with the YJIT, but I think some. I have some ideas to make a faster runtime performance and faster warm-up time. So I want to try maybe in few years. So and maybe it doing such a thing. So I can't do it alone. So I want to organize some research team. So I want to ask someone who can help me. So I asked my company to hire more people, but they so just now, so it is difficult. So I need to find out how to organize the research team for that. Anyway, this is a last slide. So look back 20 years. So I have made, I got happy chance to contribute practical Ruby development. So I can do main interesting hacking topics like virtual machine, garbage collection, threading, concurrent execution. So I know that the lower layer of the Ruby interpreter. So I could try. So that was a very great chance for me. And also this contribution gave me many great experience, like many conferences. I can meet many Ruby friends, and I can go many countries, and I got a job, so 4 positions in past, and I got married and got children, and they are healthy right now. So that was very nice. So I can only have gratitude to happy 20 years. So I talked that 20 years of development of YARV, and I want to say thank you for using the Ruby and YARV on your computer. Thank you very much.